Hello, ladies and gentlemen. Welcome to another pre-calculus for business lesson with Professor Checo. Today's lesson is going to be, I can't even see it. Let's just go and preview it. I believe it's 4.2. Yep, 4.2, System of Linear Equations and Augmented Matrices. All right, let's get started. Just maximize this for a second. All right, cool. So let's go to textbook. All right, system of linear equations. So most linear systems of any consequence involve large numbers and equations of variables. It is in blah, 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 matrices. In solving systems of equations using elimination by addition, the coefficients of the variables, much as here. So let's see. Here we have, guys, a matrix. So a matrix is a rectangular array of numbers written in brackets. So here's an example. I believe this one is a 2 by 3. So as you can see, it's the number of rows by the columns. So this is a 2 by 3, and this one would be a 3 by 3. Now, matrices are able to correspond to, I guess, coordinates and principal diagonal of a matrix. This is the matrix, coefficient matrix, constant matrix, augmented matrix. Okay, oh, so here we go. Here's an example. So for example, if I have 2x minus 3y is equal to 5, 1x plus 2y is equal to negative 3, we can focus on the left side of the equation where my coefficients are 2 and negative 3, 1 and 2, and my equation is equal to 5 and negative 1. We can kind of have like this augmented matrix where it is a 2 by 3 matrix, and we can kind of solve it. So we can have the calculus solve matrices for us. Okay, so operations that produce row equivalent matrices. So just like an equation where we're able to multiply it, when we do elimination, multiply it by a number and add it, same thing where it's the same exact step that we would be able to do it here. So if you have this linear equation, what you would do, since it's x1 and x2, you would either add 2 over here, substitute that into there, solve the equation, and do that. There is a much easier way, which is using augmented matrices. So this is just basically a bunch of work. I think I'm going to be able to do this by hand. I'm not going to try to do this by hand because it is very complicated, because basically what you're doing is you're getting it to look like this. So here's the equation. 3, 4, 1, negative 2 is equal to 1, 7. So the first step they do is they need a 1 here. So what they do is they just switch them. So you're able to switch an equation just like you can switch equations. Then you're going to want to multiply the first row by negative 3 and add it to the second row. So here they multiplied row 1 by negative 3 and added it to the second row. So they did that, and then they got this. Then you're going to want this value, this y1 or 1y, to be a 1. So divide by 10, and then you get this. Then we're going to work backwards. You need that to be a 0. You multiply this row by 2 and add it to the previous one, and then you're able to solve the augmented matrix. So that's what it is. And if you're able to do a row echelon, row swap, this is some fancy stuff. This is just solving. Systems of matrices, all good. Solution, solving. So summary: possible final matrix forms for a system of 2 linear equations is 1, 0, m, which means x is equal to m, and then 0, 1, y, n, y is equal to n. Or here you have 0, 0, and then this would just be a line, which means this is infinite solutions. And here, this one would be no solution because 0 is equal to a number, and then that's not true. So based on the 3 solutions, kind of like when you solve it linearly, you're able to get it. All right, let's take a look at what this is going to be. All right, determine the size of the matrix. This is a 3-column. This is a one row by 3 column. Here, this one is a 1, 2, 3, 4, 5 by 1. This one is a 1, 2, 3, 4, 4 by 4. Hold on. Yeah, this one's 3 by 3. I'm just gonna make sure I get all these. Let me go to the previous question. That one. Oh, submit. Check answer. Cool. Oh, this is a square matrix because it's a square. Going to the previous one, this one is a, what does I say, 1 by 1, 2, 3, 4, 5, 1 by 5. 1 row, 5 columns. oops. This matrix is a row matrix. Dang it. This is a 2 by 2. And this one is a square. This one is a, the elements on the principal diagonal are, I think you multiply this. 8 times 7 is 56. What's 56 times 3? Where's Desmos? 56 times 3. 168. Let's check. The elements on the principal diagonal are, view an example. Huh? It's 12. And then what do we do? Oh, just a comma? Oh, you don't multiply, you just comma them. I'm sorry. I thought you multiplied them. So 8, comma 7, comma 3. Oops. Select the correct choice for each one. Identify a second row, third column, -6, -6, and 1, 1 is 3. Write the coefficients of the matrix. So your matrix is 2, 4, 4, -5, because it's the coefficients in front. What is the augmented matrix? So you're going to write the same exact thing. 2, 4, 4, -5. Over here is going to be a 6, and underneath is a 7. At least for this example. All right, what's the coefficient? Same exact question, guys. This is, and then what's the augmented? No problem. So what would the first, okay, so here we want to use x1 and x2 type equations using x1. So my equation here would be 3x, how do I do subscript 1, x1 plus 4x subscript is shift underscore x2. Write the equation represents the first line is equal to 7. Write the equation that equals the second line. So that's going to be x subscript 1 plus 2x subscript 2 is equal to 9. There you go. Moving on. Same exact thing here. Okay, so now perform the row operation. So switch row 1 and switch row 2. So 5, -5, -3, -7. Oop, typo. -7. And then we have 1, -2, 5. Easy, steamrolling along. So then here you would multiply row 2 times 7. So then this is going to be 1, -3, 2. 4 times 7 is going to be 28, -42, and 7 times 8 is 56, -56. Cool. So now here they want you to do -1/4. I think I'm going to skip this. I think you guys get it. Divide the entire row by 4. Here you would multiply -1 times row 1 and add it to row 2, and then rewrite it there. So -1 plus row 2 gives us a new row 2. So then this is going to be 1, -2, 4. What is 4 minus 1 is 3. -2 plus is -3. And what's -8 plus -8 minus 4 is -12. There you go. All right, the matrices below have results of a performing single from here to there. So what happened from here to there? Well, it looks like the row 1 was divided by 2. So 1/2 of row 1 gave me the new row 1. There you go. What happened here? So it looked like I took this divided by 5. So then 1/5. 1/5 of row 1. Yeah, 1/5 of row 2 plus row 1 gives me row 1. Here, solve the system of equations. Let me see if I can do a matrix. Can I add a matrix? How do I add a matrix? Let me see if I do a line. Nope. Shift line. And I don't know how to add a matrix. M-A-T-R-I-X. I don't know how to add a matrix. Nope. I don't know how. Expression maybe? No. Let's go here. Table. Functions. Let's look for a matrix. Nope, that's max. Yeah, no, I can't do anything there. But what I can do is I can say this is 5x minus 3y equals 20, followed by 6x minus 5y equals 10. So as we can see, there is a point of intersection at 10, 10. X1 is equal to 10. X2 is equal to 10. Boom. 10. Check. Fantastic. Continue. Which graph represents? It's that one. Oh, I missed it. Oh, I'm sorry. Which graph represents the solution set? Just the point 10, 10. See that little point right there? Yeah, that's it. And then the last question: what is the difference between the graph of the equation in the system and the graph of the system solution set? The graph of the equation is a point. This one, the graph of the equation is a line, whereas the solution set is a point. Spot on. Moving on. So here I'm just going to go ahead and graph this. So now I'm going to do 5 minus 4 equals 7. And then that's going to be 21. That's going to be plus 12. And that's going to be minus 15. Oh, these guys are parallel. There is no solution. Isn't this times 3 that? Oh, there's a negative 7. My bad. So there's infinite solutions because they're the same line. This doesn't have infinite many solutions. The solution is, what is this line? So if this becomes t, then it's going to be x equals negative 7 divided by, oh, I should put that up there, negative 7. What is that going to be? Plus 4t divided by 5, because you got to solve for y equals. There you go. Moving on. The graph is a line because the solution is all the points. Continue. The solution is the equation line where the graph is set. Graph is infinitely many points. What? The graph of the graph is a line where the graph is a blank set. Oh, because it's infinite, there is no difference between the. Oh my goodness. Okay, so here, let's go through it. This is going to be again 1x minus. Oh, this is super easy, guys. This is x equals negative 6 and y equals 9. This one is, because you have 0 is equal to 1, there is no solution. Because 0 equals 0, there are infinitely many solutions. So x1 equals 16 minus, plus 16 plus 3t. Because it's y equals negative 1x. I'm sorry, y or x, you know what I mean. x1 minus 3 x2 is equal to 16. Solve for x1. Boom. Moving on. Here, what is that? X minus 3y is equal to negative 1. I'm using Desmos, guys. Like, this is just, I want you to understand. We have technology. Utilize it. Minus 1 y is equal to 5. And my intersection is 2, 1. So that's going to be 2 comma 1. Moving on. Here we have 2 minus y is equal to 6. And then x plus 5, 5y equals 14. Now, guys, if this is the midterm, I'm taking screenshots of this. Like, I'm going to show my work. Like, I'm getting all, like, I'm not going to let anyone think anything is not. So here we have infinite many solutions. So if x2 is t, that's going to be a fraction. So it's going to be 6 divided by up front. 6 plus t divided by 2. What? Two x minus y is equal to 6. X plus 5y is equal to 14. Oh, there's an intersection. That was dumb. 4 comma 2. 4 comma, oh my god, comma 2. Good. Same exact thing here. Same exact thing here. Same exact thing here. Same exact thing here. This one is just decimals, so I'll do that one because just to prove it's like no problem, guys. We're using technology. It's not going to be an issue. Minus 40.32 is equal to 308.88, and then this equation is going to be negative 3.25 plus 23.7 equals negative 183.0375. I'm going to zoom way out. And my intersection is somewhere right there. So the solution is 3.45. And my y is negative 7.25. Cool. Check it. Oh, 3.45. I put 25. 3.45 negative 7.25. Check answer. There we go. And that's the assignment, guys. So really, system of linear equations and augmented matrices is really simple. All right. Best of luck. To the next one.